Let's continue our work in chapter 13 with graphing lines or inequalities. In this problem, we're given the slope, which is -5/3, and the line passes through the point 5, 6. The first thing to do is graph the location first. So we're going to graph 5, 6. So go over 5 and up 6 and put a dot. When we talk the slope, we need to rewrite -5/3 with the negative sign in either the numerator or the denominator. We're going to move the negative sign to the top or bottom. We can either write -5/3 as -5 over +3 or +5 over -3. To use the slope, the numerator tells us how much we move vertically, and the denominator tells us how much we move horizontally. So from the given point, let's use this form of the fraction or the slope. So from this point, we're going to come down 5, and we're going to go over 3, which gives us a second point. We can then draw the line. Notice the line has a negative lean downward to the right. We could have used this fractional form of the slope. Again, starting at the same place, we would have gone up 1, 2, 3, 4, 5, and we would have gone back 1, 2, 3. We get the same line, but a different point. We're now going to graph a line in what we call a slope y-intercept format. So we're going to compare this equation to y = mx plus b. If the initial equation is not in this form, you need to solve the equation for y first so that you can compare and say that the m is the number that multiplies the x, which is -4/5, which can be written as -4 over +5. And the b is the coordinate of the y-intercept. The b is 5, or the y-intercept is 0, 5. The first thing we do in plotting is to plot a location, which is 0, 5. From that location, we're going to use the slope, which says we need to come down 4, and we need to go horizontally 5 units to get a second point. Notice when we draw the line, it's a downward slope, meaning a negative slope value. An alternate method than the y = mx plus b format would be make a little chart. Choose appropriate values of x, calculate the corresponding value of y. So we're going to let x = 0, 5, or 10. If we plug x = 0 into the equation, the -4/5 times 0 is nothing, at 5 is 5. When we plug in x = 5, I chose 5 rather than 4 or 6 because I want to work with whole numbers. If I put a 5 in here, it reduces with the denominator 5, so I end up with -4 plus 5, or the value of y is 1. Another good choice for x, again, is a multiple of 5 in this case, so that it can react with the denominator that is 5. Plugging in 10, -4/5 times 10 reduces to 2 times -4, which is -8, plus 5 gives me a value of -3. And I can plot the 3 points. Let's plot the last one, x = 10. We go out to 10 and down 3, you see we're on the line. So here are 2 different methods of graphing this equation. We're now going to graph a linear inequality. Just one extra step when we're working with an inequality. We need to shade an area. We want to graph this inequality. The first thing to do is to solve it for the letter y. So 5y is greater than 2x minus 10. Divide each term by 5, so y is greater than 2/5 times x minus 2. We need to plot the equality since it wasn't given. So make it an equal sign here and let's plot. All right, the y-intercept is -2 on the y-axis. The slope is 2/5, means that we're going up 2 from that location and over 5. That gives me a second dot. And when I draw the line, notice it's upward because the slope is positive. I made the line dashed because the original problem does not have an equality. It's a greater than. So the line is not included in the answer. What's included in the answer, if we have a greater than symbol, after we solved, then we shade above. If we have a less than symbol after we've solved, we shade below. Just in case we made a mistake in our solving and shading, we want to use a test point plugged into the original inequality. Let's use 0, 2, which is this point. If this point satisfies the inequality, the original inequality, we know we've shaded correctly. Plugging it in, we have -2 times 0 plus 5 times 2 gives me a value of 10. 10 is greater than -10. So that point should be shaded and all corresponding points. And finally, we're given an inequality and we're asked if this point 4, 0 is a solution to the inequality. So we're going to plug in the point. For y, we're going to use 0. For x, we're going to use 4. -1/4 times 4 is -1. -1 plus 5 is plus 4. How does 0 compare to 4? 0 is less than 4. 0 is less than 4. Notice we have a greater than symbol up here. So therefore, that point is not a solution.